Good day, my name is John Vincent S. Saracanlao. You can call me Sir John or Dr. Saracanlao. Our lesson for today, because this is lesson 14, 16 something, is on multiple linear regression. Multiple linear regression is an extension of simple linear regression, which was discussed earlier in this previous video. It is when two or more independent variables are used to predict the value of an dependent variable. The goal of multiple regression is to find a fit variable or variables that can make a good prediction of the y variable or the dependent variable. It is not about randomly using variables to predict the y variables as a regression model. So most often, I've seen in different researches as I work as a panel or a consultant, they just use different random variables to make it to run a multiple regression. When in fact, it's not that supposed to be like that. It's about finding the fit variables to predict the y. You don't just use different random variables, put it in, run a regression, and there. Because regression, multiple regression, has a lot of conditions from which you're able to run the model, and not compared to simple regression, simple linear regression, which already has a lot of conditions. Plus, when you do multiple regression, you add more conditions. So conditions in multiple regression is the same as stated in simple linear regression, but two additional more conditions. One, overfitting. It is caused by adding too many independent variables. It accounts for more variance, but adds nothing more to the model. Two is collinearity. This is when independent variables are highly correlated with each other, and those two independent variables are paired with your dependent variable, and that will cause collinearity because in the plot, they're basically, since they are very they are very highly correlated, so more or less it will create a collinearity. The primary reason to avoid overfitting is because each variable in a multiple regression affects each other and the result of the whole regression model. Randomly adding variables without background literature or sense of is counterproductive to what the statistical tool can provide, which is the estimate of y or the dependent variable, with that data from not just one variable but two or more variables. So when you're using multiple regression, it's not just randomly adding variables, but you're trying to find a fit to predict your y. So in terms of collinearity, results will indicate inconsistencies between the entire model, the f value, and the probability value, and with the t value and its probability value of the independent variable. So in terms of collinearity, it will affect a lot of the results. So that's why when we do multiple regression, we do we test them first for overfitting and collinearity. However, there are two ways to identify if the independent variables are collinear. One is with correlation, and the other is with VIF, variance inflation factor, and above. So formula for VIF is 1 over 1 minus R squared. So when doing a calculation in Excel, so step 1 is copy paste file for calculation in a new sheet. Then click data, data analysis, then regression. So data analysis, regression. Independent variables in your X range, and click level confidence, labels confidence output range, and your dependent variable in your Y. So enter the dependent variable in your Y and X in your for your independent. And for from the results, look for the empty cell to calculate your VIF. So in an empty cell, that's your empty cell, look for a VIF. So 1 over 1 minus cell of R squared. So that's B16. So 1, open parenthesis, 1, close parenthesis, slash 1 minus B16, and you will have your VIF. The VIF is 3.34, referred parameters of collinearity. So, where's our parameters collinearity here? There. So when the VIF is, since the VIF is 3.34, it's here, so it's moderate collinear. So what do we do? We can technically run, since it's not severe collinear, but as I said, it will affect the results. And remember that our data here is not more than 200 respondents. So probably that's the reason why it's very collinear, because the plots are very the same, and we already know that based on calculation, they are both independent variable are already highly correlated. So what's the decision here? Go for it, but ideally there should no collinearity between two independent variables. The results show in line that with the reasons to avoid collinearity stated above. The results show inconsistencies between the entire model. Oh yeah, I think no, no. So crash that out. So since it's moderate collinear, no. So the results shows that inconsistencies between the entire model, f value, and its probability value, which indicated the whole model significant. The t value and probability value and other independent variables is considered significant, but the others is not. So yeah, so it will affect the result. So it is highly recommended that when you do uh, multiple regression, aside from the discussion on conditions for simple linear regression, it should not be collinear. Since there is moderate collinearity and high correlation, it's suggested not to run the model. However, do not be concerned or be overwhelmed with that idea that, oh, I cannot run multiple regression analysis because the variables are collinear. Uh, there's also overfitting. I will be discussing statistical tools after this one that you can use because you cannot use multiple regression analysis. And they are good statistical tools also. So when you do your research and you do the analysis and you're already projecting that, oh, what if I cannot use multiple regression? What will happen to my data? What will happen to my research? Uh, it's good to have that projection, but don't be anxious about it because I'll still be discussing different statistical tools that can process the data because we cannot process it on another tool, such as multiple regression analysis. So the result, in addition, because of the collinearity of the independent variable, the calculation resulted to a negative intercept concept, a negative attitude towards reading and comprehension, when in fact, based on earlier calculation, there is a moderate but positive correlation between attitudes towards reading and comprehension. So as you can see, the model is destroyed because of collinearity. In previous analysis, there was a positive, moderate but positive. Now it's negative because of effects of collinearity. So this means that, however, the result indicates that there's a negative coefficient. This means that for every unit increase in attitudes, there is corresponding decrease in comprehension, which is not consistent to the previous results. So that is how it affects when you have collinearity. Then, okay, so we also have overfitting. So from that, I'll be discussing frequency-based analysis after this video, so that even if you don't have, if you cannot use the multiple regression analysis because of the conditions that are not met, we still have frequency-based analysis from which you can process your information or your data that will still yield to a productive result or something that you can use for your recommendation or for your findings as well. So I'll end that video here. Thank you and have a good day.